IPv6 and routing. This 5 router scenario, we are going to do static route, default route, routing protocol, RIP, EIGRP, OSPF, BGP, and all this. For that, first we'll start with static route. In this router R1, show IPv6 interface brief. I have these two subnets. One is 12, the other one is 1111. So 1111 is on loopback interface and subnet 12 is on Ethernet 0 interface, Ethernet 0/0 interface. The rest of the networks which is there in the other routers are unreachable for this router. Show IPv6 route. You can see the route. We have the routes only for the directly connected Ethernet 0/0 and loopback. For the rest of the network, we need to write a default route. So how to write default route? IPv6 route, just ::/0. Show run interface Ethernet 0/0. So this is what we have given on the interface. 12::1/64. And on the loopback interface, this is what we have given. 1111::1/120. There's no other subnet. So we need a default route to reach the other subnets in this topology. For that we need a default route. I write IPv6 route. Any network, any mask. This is the meaning. Any network, any mask. Send it to next router. Next router's IP address is 12::2. So this means default, which means any network this router don't know, it will send it to this gateway. This is the IP address of router 2's Ethernet 0/0 interface. You can also try pinging it. Ping 12::2. It will ping. It pings. It's the very next router's IP address, which is going to be the gateway for R1's unknown networks. Let's verify this. Show IPv6 route. You can see here, yes means static, and this is what the default route. Now, if I'll ping the loopback address of R2, I will ping. I should be pinging this. Yeah, it pings. How I ping it, even though I don't have a route for 2222, I ping it because I have default. Means any network. Send it to router 2. And this is router 2's loopback interface address that I'm pinging. Similarly, I can write a default route on R5. On R5, show IPv6 interface brief. Only these are the two IP addresses I have. I'm going to remove this. This belongs to actually R1. Interface F0/Ethernet 0/0. No IPv6 address. Interface loopback 0. No IPv6 address. Alright, so I removed it. Show IPv6. I can see that there are only two subnets on this router, 45 and 5555. Rest of the networks you need a default route. So once again we are writing default route, IPv6 route, any network, any subnet mask, send it to router 4. Router 4's address is 45::4. So now show IPv6 route. I should see a default route and I will be able to ping 444::4, which is on router 4. But unfortunately it's not pinging. Let's troubleshoot it. I'll go to router 4 and check the configuration. Show IPv6 interface brief. I see that there is a duplication. There is a wrong address. Means this is supposed to be 4, not 5. On router 4 it should be 4. So interface Ethernet 0/1, no IPv6 address 45.-/2464. Let me cancel this first and then I'll put the right IP address. IPv6 address 45::4 4/64. Now I'm expecting the ping from R5, which was not happening before. From R5, when I ping now, I'm able to ping because the gateway is available now. Alright, on the rest of the routers, we need to give a static route. We cannot have default route. So on router 4, what I'm saying is, on router 4, I'm saying IPv6 route. If you wish to go to 12 network /16, I'm saying just match the first 16 bit. If you will find 12 matching, then you need to send it to whom? You need to send it to R3. So R3's address will be 34::3. You don't give interface address. We don't give interface address on loopback. On IPv6. Exit interface address we don't give. We give only the IP address for the gateway, because we don't have ARP to broadcast. So we do only provide the IP address. No, we don't give our interface address anyway at any time. We give exit interface name or the next router's address in IPv4. In IPv6, you give only the next router's address. You don't give your interface name. One more static route I need to write. No, not one more, two more. For loopback interface of R2, for loopback interface of R1, and for loopback interface of R3. Right. Alright. So what is next is, alright. So what is next? Next is I have got R4 ready, I believe. R4 is ready. Let us check the routing table. Show IPv6 route. So we got static routes, everything in place. Next is an R3. On R4, one more network is missing. What is that? R5's loopback. R5 is loopback, there is no route. So let us write one more route. R5's loopback address is this 5555 colon 5. We need to send it to 45 colon 5. Sorry, I made a mistake. 5555. No need not. If you want to mask it completely, you can mask like this. Alright. So router 4 knows about the loopback interface of R5. R5 knows about the loopback of R4. Because in R5 we have written a default route. Now if I will ping 5555 colon 5, this will definitely ping. Not only that, if I source it with my loopback 0, that also will ping. Here I have sourced with my loopback address. Because I have static route from R4 and default route from R5, this ping is possible. Similarly, we have to configure static routes on R2 and R3 if we wish to ping from anywhere to anywhere. So any question, do we need to really do the other routers, the static route configuration? I don't think so, because it's going to be this. Yep, same time, only the gateway will vary. Okay. So in R2 what I'll do is now, I'll show you that now I was telling you not to use interface. But there is an option to use interface, but don't use it. Say for example on R2, I'm saying IPv6 route 1111 colon 1 slash 128. Send it to router 1. Router 1's address is actually 12 colon 1. But instead of saying that, if I say interface or Ethernet 0/0, it takes. But when I try pinging, the ping doesn't happen. It never happens. So I recommend you only to use gateway. Yeah, the gateway address, IP address. So what I do now is 12 colon 1. When I put, this ping will happen. Immediately it pings. Let us try some other options. Can I have interface? Can I have interface along with the IP address? Yes, this you can do it. Interface and IP address, it will work. Colon 1. What? Oh, I have no. I need to remove this. Okay. Alright. Let me remove the old one. This was the old one. I removed the old one. Now I have interface along with the IP address. Show IPv6 route. I have a static route with the interface and the gateway. Will this ping happen? Definitely it will happen. This is allowed. So use interface and IP address, or you can use only the IP address, but do not use only the interface. Do not use only the interface. One more time, I'll show you another example. Show IPv6 route. You see, there is no route for 3333. So I'm going to write a route to reach 3333. IPv6 route 3333 colon slash 16. I can say send it to 23 colon 3 or 23 colon 3 along with, okay, order is also very important. First comes the interface, Ethernet 0/1 and then 23::3. Now when I ping 3333::3, I should be pinging. It's pinging. Correct. The IP address should be the next router's IP address. Next router's IP address. As you said, it should be the destination router's IP address, which will be the next hop address. Destination means not the final destination, the very next router's IP address. For router 2, you may be willing to reach destination 5.5.5.5555, which is final destination, which is very far. But for router 2, first of all, you need to send it to router 3. So it should be your router 3's IP address and your exit interface address. Your own exit interface address and your next hop address, which is router 3 in our case. Any questions? Right, now what we are going to do is we are going to remove this default routes and the static routes, and we are going to go with the routing protocol. And first routing protocol will be RIP. Show run section IPv6 route. I'm going to remove this too. Similarly, I'll also remove default route that I gave on R1. Router 4, I have given some routes, so I'll say show run section one last router I need to remove, which is R5. Done. So what is next is a routing protocol. RIP is like this. You go under the interface only. You need not do anything on the global configuration mode. Go under the interface Ethernet 0/0, IPv6 RIP, and then we need to give a name. We need to give a name to identify the RIP process. Name can be anything. So I'll say RIP Shakti. Okay, one more command, enable. So just to say that, it can be any name. I'm using the word Shakti here. Now, I go under interface loopback 0 and enable same RIP by using the same command IPv6 RIP Shakti. So RIP is now enabled on these two interface, Ethernet 00 and loopback interface. You can verify this by typing show IPv6 protocol. We can see that RIP in the name of Shakti is running, and it is running on loopback 0 and Ethernet 0/0. Similarly, we are going to do it on router 4. I can use the range command, interface range Ethernet 0/0-1 IPv6 RIP. So I'm doing configuration on both the interfaces, physical interfaces, at the same time. So range command. It is available in 15. Later version, 15.x version of Cisco IOS. It was available only on the switch before. Now it is even available on the router. Now IPv6 RIP. There I gave Shakti, where in R5. You need not to give the same name here. It can be different name also. So this time I'm going to give Iqra, IQRA, enable. So RIP is running on these two physical interface. I also want to enable it on loopback interface. So I go under the loopback. I give same Iqra. Now RIP is running on these two router. If it is true, then I should see the routes from R5 in this router. Show IPv6 route RIP. See, if through RIP I am learning this IP address, this subnet, and you see it is showing the next hop address as the link local address of R5, not 45.0.0.5. This is a link local address of that 45.0.0.5. I told you, link local address is what used to do neighbor discovery. So this shows the neighbor. Every routing protocol discovers the neighbor using link local address. Now if I ping, I'll be able to ping. It's pinging. Similarly, if you go to router 5, show IPv6 route RIP, you can see these routes. One is 34 and the other one is 444. So I can ping now 34::4. I can also ping 4444::4. Right, so RIP is easy, very easy. So let's go and do it on R3. Interface range Ethernet 0/0-1 IPv6 RIP. Give any name. This time I give name SYM enable. Interface loopback 0 IP RIP SYM enable. Now if I go to router 5, I should be seeing more routes than before. See, I'm able to see the routes from R3 also. So now I can ping an IP address on R3. 23::3. You're pinging. So RIP is that easy. We need to just go under the interface and say IPv6 RIP name enable. Name can be different, can be same. I have given different names. In R3 I gave SYM because I am seeing my keychain having the word SYM, Mahendra's scooter key, SYM. And on router 4 I gave a name called IQ array because I am seeing in my left there is a scissor which is used to cut small things. That scissor company name is IQ array. And on router 5 I gave name Shakti because I am seeing the mouse mosquito killer night lamp which is from a company called Shakti. What I'm coming to say is name can be anything and they are locally significant to the router, and if you keep the same name on every router then also okay, so that you won't have confusion when you do troubleshooting. Just to show that the name need not to be same, I used different name. Now we are going to remove this routing protocol. See, show IPv6 protocol. We are having RIP. To cancel this, there are two ways. One is no IPv6 router RIP Shakti. See, this I am not doing under the interface, this I am doing globally. This is one way. I have cancelled RIP. You can see that now, show IPv6 protocol. It is cancelled. It's no more. I see static, I see neighbor discovery. I don't see RIP in the list. The other way is I'll do it on R4. On R4, if you see show IPv6 protocol, you are having RIP here, Ikura. How I'm going to remove, I'll say no IPv6 unicast routing. When I remove this, all the routing protocol will get removed. You see now, show IPv6 protocol. Gone. RIP is gone. Now I'll put back that command IPv6 unicast routing. Show IPv6 protocol. See, there is no RIP. One more router I need to remove RIP, which is R3. How do we do it? No IPv6 unicast routing. IPv6 unicast routing. That's it. Show IPv6 protocol. We will not see RIP there. So the next routing protocol that we have in the list is EIGRP. Let me show you how to enable EIGRP. Only thing is, in EIGRP you need to start the IPv6 software package like this. IPv6 router EIGRP. You can give a name here or a number. Okay, only a number. I'll say 10. And then you need to say no shutdown. That is what I said when I say you need to start. You need to say no shutdown to start the EIGRP IPv6 algorithm. We used to give no shutdown only on the physical interface. This is not physical interface. This is routing protocol. It has been shut down by default. We are enabling that process. After this, you need to go directly to the interface. You cannot do any network command there. So go under the interface as usual as you did for RIP. Say interface range Ethernet 0/0-1 IPv6 EIGRP 10. That's it. There is no command called enable and all. Interface loopback 0 IPv6 EIGRP 10. Next, similarly, router 4 I'm going to enable. Before that, let us do some verification. Show IPv6 EIGRP interfaces. Okay, it says no usable router ID. For this routing protocol, you need a router ID. It should be 32-bit identification number. So for that, there are two ways. One is you can create a loopback interface with IPv4 address, interface loopback 0, IP address 3.3.3.3. This is not going to be used by us for anything. Only a routing protocol like EIGRP, IPv6, EIGRP and OSPF IPv6 will use it. So now when I type show IPv6 EIGRP interface, I can see that these three interfaces are running IPv6 EIGRP. And router ID is mandatory. The loopback interface address will be automatically picked up as the router ID. If you don't have any IPv4 address, then you need to manually give the router ID. How? Like this. IPv6 router EIGRP10 router ID, EIGRP router ID 4.4.4.4. Now you need not to have any physical interface or logical interface with IPv4 address. You don't need to give that since since the router ID has been given directly. And no shut, you should give this command without fail. Now go under the interfaces, interface EIGRP 0/0-1. Let me try loopback. Come on, won't work. Fine. Interface range. Interface range Ethernet 01. EIGRP is already on. We have said no shutdown, and we are simply saying here IPv6 EIGRP and the autonomous system number. Only this much. See, we are seeing that EIGRP forms neighbor using dual algorithm, same algorithm that is there in IPv4 EIGRP. Same algorithm is used in IPv6 EIGRP, and this is the autonomous system number that we are using. You see, the neighbor discovery is even here, it is by the link local address. It is not saying that my neighbor is 34:3. It says the link local address of that 34:3. I can show you that on R3. If you see here, show IPv6 interface brief, you can see this link local address and this link local address will match. R4. This link local address that you see has got 310, and what I'm saying is this interface Ethernet 01 will also have the same address. This interface, yes, see, Ethernet 01 has got the same link local address. So it is using the link local address the neighbors are discovered. Yes, it's a unique identification for the next hop. That link local address is made out of MAC address. Only FFFE is inserted in the middle, and the 8th bit from the left is inverted, and FE80 is the subnet. Alright, so link local address is what used by routing protocol to do neighbor discovery. Now, when I check the routing table, show IPv6 route EIGRP, I can see the routes that are learned through EIGRP. I can ping one if I want. It pings. So EIGRP is only this much. So let me repeat one more time so that we will not forget. On R5, I'm going to repeat this. R5. As of now, show IPv6 protocol. I don't run EIGRP. I'm going to run now. What's the step? IPv6 router, EIGRP autonomous system number, EIGRP router ID 5.5.5.5 if you don't have an IPv4 address, and then no shutdown. Mandatory. You cannot use network command here and advertise. There is no command networking in first place. See, there is a neighbor command. There is no command. There is no other command starting with N. So all that you need to do is go under the interface. Interface Ethernet 0/0 IPv6 EIGRP 10. That's it. Similarly, interface loopback 0 IPv6 EIGRP 10. Alright. Now when I go to router 3, I should see the routes from R5. Show IPv6 route EIGRP. I'm waiting. I'm expecting the route. But I'm not seeing the route from. Oh, I'm seeing already. 5555. It's there. Ping : 5. It pings. Let me check. Show IPv6 EIGRP interfaces. See, I'm not running loopback interface of R4 under EIGRP. So let me run now. IPv6 EIGRP 10. Okay. Now you will not have any confusion because you're going to see one more route here. See R4. Now when I ping, no, you are advertising. No, the subnet has to be advertised in EIGRP. See, previously I was running EIGRP only on these two interfaces. Now I am also running EIGRP on this interface. If you want that loopback interface to be advertised, if you want the address on the loopback to be advertised, you need to run EIGRP there, right? Only physical Ethernet 00 and 01. Yeah, we were receiving it. I'll show you. Previously you were receiving the physical interfaces on R3. See, previously we were having this. We were learning 45. We were learning 555. Why you are not learning 34? Because it is directly connected. You will not learn through EIGRP. I'm checking it on R3, right? So only this much I can see. Right. Now one more protocol, OSPF. So how I am going to cancel this routing protocol? No IPv6 unicast routing. Done. Similarly, let me cancel from router 4. No IPv6 unicast routing. One more. This is router 3. No IPv6 unicast routing. Alright. Show IPv6 route, EIGRP, nothing. Gone. Let's run OSPF. First command, IPv6 unicast routing. In OSPF, you can do everything on interface if you will have a loopback interface with IPv4 address. If you don't have an IPv4 address, then you have to provide router ID manually by getting into the global mode. But I remember in router 3, I have a loopback interface address. Show IPv4, show IP interface brief. You see, I have a loopback interface address, so I can go straight to the interface interface loopback 0, IPv6, OSPF, process ID, area ID. Interface range, Ethernet 00-1, same like IPv4. So now verification. Show IPv6 OSPF interface brief. You see these are the three interfaces running EIGRP, sorry, OSPF. Let me do it on one more router. No, we don't have static anywhere or dynamic default anywhere, and I'm not taking these routers now. The reason is you are understanding how to configure when I do it on just two routers. So I did it on R3, now I'm doing it on R4. If you want, I can do it on R2 instead of R4. I'll go to R2. Okay, on R4 what I'm going to do is I'm going to say, because I don't have a loopback interface with IPv4, see show IP interface brief. I don't have any IPv4 address. Because you don't have it, we need to do this. Router, IPv6 router, OSPF process ID. Okay, before that IPv6 unicast routing has to be done. Otherwise it will show this command, show this error. And then get inside OSPF and say, see what it says? It says, I couldn't pick the router ID, so please provide it manually. I'm going to give it manually. Router ID is 404.404. And then go under the interfaces, interface range, Ethernet 0/0-1, IPv6, OSPF, area. See, OSPF has formed neighbor. Interface loopback 0. There also I would like to run OSPF. Done. Now if you check the neighbor, show IPv6 OSPF neighbor, you can see the neighbor is seen here as the router ID of the neighbor. Even though it is an IPv6 neighbor, the identification for the neighbor is not the IPv6 address. It is the router ID. But again I tell you, still the neighbor discovery, everything happened through link local address. What is the proof? Check the routing table. Show IPv6 route OSPF. You can see that the next hop address is only the link local address. It is not the router ID or the physical interface global address. It is only the link local address. So running OSPF is very easy. One more router I'll show you so that we won't forget. IPv6 router OSPF process ID, router ID, exit. Only for EIGRP you need to give no shutdown, no other protocol. And then, sorry, IPv6 OSPF process ID, area ID. Done. Now if you check the routing table, show IPv6 route OSPF, I should see routes from router 3 to not from 2, router 3 and router 4. I can also source it with my loopback. Right. For BGP there is no big difference, same like IPv4 BGP. You need to do, only thing is address family. I'll show you once. Router BGP, let's say 1, and then neighbor. Okay, router ID we need to give. Router BGP router ID is 5.5.5.5 neighbor, the IPv6 address of the neighbor. Now I'm going to give the loopback interface of R3. I'm going to form neighbor between 5 and 3 IBGP. So neighbor is 3333::3, remote AS is 1. And next is address family IPv6 unicast. And then again you say the same neighbor 3333::3 and activate the neighbor. Now one more thing I forgot to do. What is that? Because we are using loopback interface address, I need to say update source loopback 0. Done. Yeah, of course you need to have the IGP protocol. We are running OSPF now in this 3 router. This is the neighbor address. This neighbor should be pingable. Correct? See, it's pinging. To form neighbor, this neighbor need to be a pingable address. That's why I have IGP. Right. Now I'll go to router 3 and form neighbor with router 5, IBGP neighbor. Router 3, router BGP 1, router ID, BGP router ID. Because I have loopback interface, it will take automatically, so forget about it. Neighbor is 5555::5, remote AS is 1. And to this neighbor, update source is loopback 0. Now IPv6 is not running for BGP is not running under IPv6. To enable it, I say address family IPv6 unicast. This activates the IPv6 BGP, and I say neighbor 5555::5 activate. Now you're going to see neighbor forming between 3 and 5. See, it says BGP adjacency neighborship is come with 5555. Show IPv6 show BGP IPv6 unicast summary. You can see the neighbor is already established. So we have seen so far in today's session, like static route, default route, routing protocol RIP, routing protocol EIGRP, OSPF, and BGP. In this, the differences are this. For EIGRP, you need to give no shutdown under the EIGRP process, EIGRP mode, and also you need to have a router ID dynamically assigned from any of the IPv4 interface or IPv4 address on the interface, or statically. For OSPF also you need router ID, and for RIP you need to configure RIP, and you need not to give a router ID. Router ID is not necessary for IPv6. Router ID is not necessary for IPv6 RIP. When you configure, you need to configure with a process name under the interface. You remember I gave Shakti, Icura, and SYM as a name. For BGP, address family is what? Important. Other than that, nothing is important. You need to have reachability to the neighbor address. Any questions?